For more than 60 years, a rhythm has been pulsing deep within the Earth. A steady, unceasing beat, once every 26 seconds. It is not thunder, it is not an earthquake. It is a heartbeat. A planetary heartbeat that has been echoing beneath your feet your entire life, and to this day, no one on Earth knows why. We are about to journey to the precise point of origin of this global hum, a location pinpointed on the deep ocean floor. You will see the original seismic readings that first exposed this phenomenon, and we will unpack the official explanations that have completely failed to solve it. Finally, we will confront the unsettling data that suggests this constant, rhythmic signal may not be a natural occurrence at all. The official record begins in 1962. A geologist at the U.S. Geological Survey named Gary Holcomb noticed something strange in his data. A persistent, tiny seismic flutter, a microseism. It was too regular, too clean to be random noise. Around the same time, a researcher at Columbia University, Jack Oliver, documented the same phenomenon, noting it seemed to originate from somewhere in the South Atlantic and was strongest during the Northern Hemisphere's summer. But the technology of the day couldn't pinpoint its source. The mystery hum was logged, noted, and then largely forgotten for decades, a quiet ghost in the machine. It wasn't until the early 2000s that the ghost was finally cornered. Using a sophisticated network of seismometers, researchers Nikolai Shapiro and Mike Ritzwaller at the University of Colorado Boulder finally triangulated the signal. They traced it back to a single specific point, not a broad region, but a small patch of the planet. The source is a place called the Bight of Benin in the Gulf of Guinea, just off the coast of West Africa. For over half a century, from this one location, a pulse of energy has been radiating outwards, vibrating through the planet's crust every 26 seconds. It beats like a metronome, a constant planetary thrum that science could now locate but still couldn't explain. Because when they pointed all their instruments and all their knowledge at that one spot on the map, the mystery didn't get smaller. It became immeasurably larger. The easy answers came first, and they were dismissed just as quickly. The most obvious culprit would be a volcano. The region has them, but the 26-second pulse doesn't match the signature of any known volcanic activity. Volcanic tremors are chaotic, messy things. This signal is unnervingly clean, a pure, almost monochromatic waveform. It's too orderly. The next theory was ocean waves. The idea is simple. Waves crashing against the continental shelf in a specific way could generate a seismic pulse. And indeed, the pulse is stronger when the waves coming from the southern hemisphere are stronger. But this explanation falls apart under scrutiny. Nothing in nature is this precise. Ocean waves are a force of chaos. They vary in strength, in timing, in direction. For them to create a signal that has held a perfect 26-second rhythm for at least 60 years is a statistical impossibility. It would be like a storm striking a piano and playing a perfect C minor chord over and over for decades. Geologists who have dedicated their lives to studying these forces have admitted in official papers that their models cannot account for it. In a 2006 report in the journal Geophysical Research Letters, the very team that located the hum's origins stated, and I quote, "Its generation mechanism remains a puzzle." Think about what that sentence really means. The people who know the most about how our planet works are telling you, on the record, they are completely baffled. This isn't an internet rumor. This is a documented, peer-reviewed, scientific enigma. Then the data revealed something even stranger. The pulse appears to get stronger during the day, local time, at its source on the ocean floor. Why? Why would a deep-sea geological event, miles beneath the surface, be influenced by the sun? Waves are influenced by distant storms, not the time of day. Tectonic plates don't care if it's light or dark. What if the models are failing because they're looking for the wrong thing? The energy involved is immense. It's far too large to be a piece of abandoned machinery or some secret underwater installation. This is a planetary scale event, a vibration that can be detected in Japan, in Alaska, in Germany, all originating from that one spot in the ocean. A rhythm that seems aware of the day and night cycle, pulsing with a precision that defies the chaos of the natural world. So, where does that leave us? With a collection of theories, each more unsatisfying than the last. The leading scientific hypothesis, championed by researchers like Garrett Euler, clings to the idea of a uniquely shaped piece of the continental shelf. They suggest this specific geography acts like a giant natural funnel, focusing the chaotic energy of ocean waves into a single, resonant frequency. It's an elegant idea, but it asks you to believe that a random formation of rock and sand has created a natural clock more reliable than most man-made ones. It doesn't fully account for the signal's purity or its strange relationship with daylight. It feels like an answer created to fill a void, not one that truly fits the evidence. The volcanic theory has been all but abandoned, but some still wonder if a bizarre, undiscovered type of magma chamber could be rhythmically filling and emptying. But there's no evidence for such a structure, and the signal's waveform just doesn't look volcanic. It lacks the explosive, chaotic chatter of the Earth's inner turmoil. The official explanation is that we just don't know. But the silence from geological agencies on this for decades feels less like a lack of data and more like an unwillingness to confront what the data is showing. This consistent, rhythmic pulse behaves less like geology and more like biology or technology. The failure of conventional science has, of course, opened the door to more radical speculation. Could it be the rhythmic breathing of some colossal, undiscovered deep-sea organism? Or is it something artificial, a relic of a lost civilization, or something not of this Earth at all, slumbering on the ocean floor and broadcasting a signal we were never meant to understand? These are not scientific theories. They are placeholders, born from the absolute failure of science to provide a rational cause. Just let that sink in. The Earth has a heartbeat, and we have no idea what's causing it. This changes how you should feel about the ground beneath you. It's not just a stage for our lives. It's an active system, humming with secrets. Every major event of your lifetime has occurred against the backdrop of this constant 26-second pulse. The first steps on the moon, the invention of the internet, every personal triumph and every global crisis. Through it all, the planet has maintained this steady, quiet rhythm. It forces you to realize that we live on the surface of a world whose most basic functions are still a complete mystery to us. We are so focused on the noise of our own lives, we fail to notice the music the planet itself is playing. This isn't just a geological curiosity. It's a fundamental gap in our understanding of reality, a constant reminder that we are not the only active force on this world. The 26-second pulse is a documented scientific fact, proof that the greatest enigmas aren't hidden in distant galaxies, but are vibrating through the very rock we call home. We've mapped the stars, but we can't explain a simple beat from our own planet. The search for that answer continues. While scientists continue to aim their sensors at the bottom of the sea, our next case file directs our attention to the sky. We're opening the investigation into the Hesteland Lights, a remote Norwegian valley where strange, intelligent spheres of light have been tracked, filmed, and officially studied by automated research stations for over 40 years. To join that expedition and uncover the data, subscribe now and continue the search for what is real.